Hey guys, how's it going? In the last lesson, we talked about the compound interest formula, and this lesson we're going to continue from that and teach you guys how to rearrange the compound interest formula to solve questions where you are asked to find something else other than the final amount of the investment. So in this question here, you can see Uh, actually, let's read the question first. The value of John's investment reached 80,000 in 3 years. If the interest was 5% per annum compounded monthly, what was the principal of John's investment initially? So we've kind of gone backwards. Last lesson, all the questions we did, we gave you the principal and asked you to find the future value. Now we've given you the future value and we asked you to find out what the principal was. So let's write down the formula. The formula was A equals P bracket 1 plus R over 100 in bracket NT. Now, so all the variables that we need values for are A, P, R, N, and T. There's 5 variables in this equation. And the question has given us 4 of the variables. So 80,000, I keep saying 800. Really should put a comma there next time. So $80,000, that is the final amount. So that's 80,000. 3 years is the time. So let's use another color here. 3 years is the time. The rate is 5% per annum. And the number of compounding periods per year is 12. As it says, it's compounded monthly, so it must be 12. And the principal we're not sure of. So what you can see is that the principal is the one we want to try and find. Now, A is equal to the principal multiply this whole chunk of stuff is actually just one term. So if we just highlight that big chunk of stuff over here, you can treat all of this as one term. So what we want to do is rearrange it so P is the subject. And if you remember in algebra, if you have, for example, A equals P times, I'm just going to make up random alphabet, let's say Y. Now if you divide it by Y on both sides, Y divided by Y cancel each other out to 1, so you are left with P equals 8 divided by Y. Okay, now in our example, Y is essentially this big box here, so we're going to move it down on the other side. So 8 divided by 1 plus R over 100 in bracket NT is equal to P. So now we can find out what the principal is by substituting these numbers into the equation. So we have 80,000 is A, so 80,000 divided by 1 plus R is 5. over 100. N is 12. To the power of 12 times 3. Sorry about the colors. Just forget the colors. Just look at the numbers. Equals P. Now, how do you type all of this in the calculator? Well, same thing as before. I would suggest that you do it slowly, step by step. So the first thing I'm going to calculate is what is in the brackets. So it's 80,000 divided by, I'm just going to do what's in the bracket first. Oops. So it's 1 plus, so I have, well actually this thing here is 1200. So I have 5 divided by 1200 plus 1. So inside the bracket we have 1.00416666. And then 12 times 3 is 36 equals P. So in the calculator, if you type in I shouldn't have deleted that, but 1.00416666, as many sixes as you can, to the power of 36, you get 1.161472. So it's 80,000 divided by what was that? 1.1614 722 equals P. So therefore P equals, and just type that last little bit in the calculator, 80,000 divided by 1.16147222, and it's 68878.10. Now the reason why I like to type one thing in at a time in the calculator is because when you type a whole chunk into the calculator, a lot of people do it incorrectly. So I would rather do it step by step, show all the working out. That way, even if something does go wrong, you should get some parts correct from the working out. So $68,878 initial investment to reach 80,000 in 3 years. Now, sometimes you might also be asked to calculate how much interest did John earn? How much interest did he make during the 3 years? Well, his final amount was 80,000. So 80,000 minus the initial amount is 11121.9. Right, that is the amount of interest that John has earned over 3 years. Okay, so now that you have learned how to rearrange the compound interest formula to make P the subject, we're going to talk about how to make R the subject. Okay, let's have a look at this question. John has $30,000 principal to invest. If he wants the future value of his investment to be $60,000 in 5 years, what percentage of interest per annum does the investment need to make if interest is compounded daily? So basically it's saying that you have $30,000. If you want it to become $60,000 in 5 years, what percentage of interest does the bank need to offer you, or however you invested the money? So we have the 5 variables: A, P, R, N, and T. A is given to us 60,000. Alright, this part here is A. The P is 30,000. The rate is, we don't know what the rate is. N is daily, so 365 periods in 1 year, and time is 5 years. So the daily part is N, and the 5 years part is T. So we obviously need to rearrange it to make R the subject. Now the first thing we want to do is put P on the other side. So remember how we said A is equal to P times K. So I just made up a whole random variable called K. So K is pretty much this whole thing on the right. That's all one term. So if I want K to be the subject, I then divide it by P on both sides. So if I divide it by P on both sides, I get K is equal to A over P, right? Because P divided by P cancels down to 1. So the first step is to rearrange it. So P is on the other side now. So we have 1 plus R over 100 N to the power of NT. So now we want to make R the subject. Okay, so I'm just going to do another example here. Now as you can see, we have the index notation. So this term raised to the power of NT is equal to this term. So I'm just going to do another example using a different color to show you. Let's say 5 to the power of 3 is 125. Alright, so you can try that if you don't believe me. 5 to the power of 3 is 125. Now 5 is equal to the third root of 125. And to type that in the calculator, you would need to go, depending on what type of calculator you have, but if you have a Windows calculator, you would do 125 and then root 3. So the third root of 125 is 5. So using that same principle, I'm going to apply it to this. Alright, we've got a whole term here, which is pretty much like 5 raised to a power is equal to this term here, which is like 125. So if we move this index to the other side, it becomes the nth root of this term, gives you this term here. So I'll just show you what I mean. So we got this term here on the right hand side, so I'm going to keep that there. Now I'm going to move this on to the other side, and look what happened to the 3 as I moved it to the other side. It goes to the root sign. So this then becomes root NT and I have a over p inside the root sign. Okay, so just a few more steps to make r the subject. Now I'm going to move the 1 to the other side. So 1 plus that equals this. So this minus 1 is equal to r over 100n. We just minus 1 on both sides. Then we're going to multiply by 100n on both sides. You can see this is getting pretty complicated. So we're going to multiply by 100n on both sides. And this part is going to cancel down to 1. So we have essentially r is equal to 100n bracket the nth root of a over p minus 1. So you must be thinking, how do we type all this into the calculator? Okay, so we have the rate, we don't know. Principal, the n is 365, so 100 times 365 bracket 365 times 5 square root, sorry, not square root, root 60,000 over p is 30,000 minus 1. Okay, so typing all this in again, I would type the difference. I would figure out the smaller sections first. So I have 365,000, sorry, 36500 bracket 365 times 5 is 1825. So 1825 here. 1,825th root of 60,000 over 30,000 is just 2 minus 1. Okay, so might do the inside first. So I have 2 and the root button here, and then 1825 minus 1. So that's this part here in the bracket. And I might as well explain what this part is. The E symbol just means times 10 to the power of. So basically this number here is 3.798 times 10 to the power of negative 4. So I'll just write that in, 36500 bracket 3.7987 88 times 10 to the power of negative 4. So the negative 4 is the last number here, and this E notation is scientific notation, which just means times 10 to the power of. And we also, did I do minus 1? Let me just do that again. 2 root button 1825 minus 1. Yep, I did. Okay, so now we're going to type all this in the actually, the only thing that's left is multiply by 36,500. So I can just do that here. So times 36,500, and that's 13.865% per annum, which is what we wanted. Now, just a quick check to make sense, to make sure that it makes sense. $30,000, if we want to grow to double the amount in 5 years, what percentage of interest does the investment need to make? And we're saying that it's 13.86%, 87%. So let's type that into our formula. So we have A equals P bracket 1 plus R over 100 N O to the power of NT. Principal was 30,000. Rate is 13.865. 100 times 365 is the compounding periods per year. In how many years did we say? 5 years. So we're basically subbing the values into our original equation with the rate of interest we found to see that if the investment grows to 60,000. So we have 30,000 times 1 plus 13.865 over 36500 to the power of 365 times 5. And 59998. That's pretty close. So when is that close to 60,000? You know that you've sort of got it correct. So you might say, well, where did our $2 go? Well, if you had rounded this off too early, or there's a couple of places where we probably rounded off too early, that might have caused a problem. Technically, you don't round any part of your calculations until the final answer. Okay, so thanks for watching the tutorial on how to rearrange the compound interest equation. See you next time.